session already I have taken. Now, today I am going to start the third session and the unit third. Already I have explained the definition of measurement as well as in the previous class I have also explained how we can measure the how we can estimate the estimation of the size of the smaller object as well as the bigger object. Now, today I am just going to explain how we can measure in regards of the measurement. We are going to today I am going to explain how we can measure the corrected length of any object. How we can measure the corrected length of any object. Corrected length object. If simply we have to find out the length of any object, then by the use of the meter scale we can find out the length of any object. But if we are more smaller length we have to find out, then we have to use the centimeter scale. That means each meter scale will consist of 100 divisions, and if it is consist of 100 divisions, that means each division it will consist of 1 centimeter. That means 1 meter equal to 100 centimeter. Again, if we want to find the more smaller length, then each centimeter will divide into 10 division, and each division will consist of 1 millimeter. That is 1 centimeter equal to 10 millimeter. That means by these scale we can find out the length of the object, that is given in meter as well as in centimeter, also in millimeter. But suppose if we are going to find out the exact length of any object or corrected length of any object, because maybe there may be some error also. Okay, so for measuring the corrected length without any error, so again I'm telling this thing, if we want to find the corrected length of any object, okay, then without any error, then we have to use the one instrument, and that was invented by Pierre Vernier. Pierre Vernier. Okay, and from its name has become, the instrument name is Vernier Calipers. That means by the use of Vernier calipers we can find out the corrected length of any object. That means if we want to find the corrected length of any object, then we have to use the Vernier calipers, and it was invented by Pierre Vernier. Okay, by the use of the Vernier calipers we can find out the corrected length up to 0.01 centimeter, okay, or 0.1 millimeter. Okay, that means if we want to find the corrected length of any object, then we by the use of the Vernier calipers we can find out the corrected length up to 0.01 centimeter or 0.1 millimeter. Okay, now come to the construction and how it will work, and major part of the what is the major part of the Vernier calipers. Right now I am going to draw the diagram of the Vernier calipers, because until and unless you are not knowing the Vernier calipers diagram, the rest of the things it will be I will not be able to explain. So see the diagram of the Vernier calipers. This one is the tail. main scale. There will be jaw. This one also there. This one also there. Here 10 division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also. And this one also, one jaw will be there. Here also one jaw. This is J1. J2. J3. J3, J4. Okay, these are the four jaws here. 0, 5, 5, 1, like that. Till, suppose I am taking the till 7 centimeter. This is called the tail. This one is called the inside jaws. Okay, this is called the outside jaws. Okay, now come one by one. I'm just going to explain it. See, there are two scales. This one is the, some more divisions will be also there. This is 6, this one 5. So this is called the main scale. This is called the main scale. And this one called the Vernier scale. That means there are two major parts of the Vernier calipers. First one main scale, and it is also known as fixed scale. It is also known as fixed scale. And second one is known as Vernier scale or movable scale. Okay, there will be two types of scaling. Just see from the diagram. This is one that is above the main scale, it can slide. Okay, above the main scale it can slide, and this one is the main scale. That means main scale will be fixed one, and the Vernier scale, that will be movable one. Okay, and here one screw will be also there. So that means if we want to fix it, that means since the Vernier scale is movable one. So if it is movable one, so if we want to fix it at any place, if we are going to find the diameter, radius or length of any object, and if we want to fix it, so by the use of this screw, this S, we can fix it. Okay, now see, there are two scales. Major parts are main scale, Vernier scale that can slide above the main scale. There are four jaws, J1, J2, J3 and J4. J1 and J2 are called the external jaws. J1 and J2 are called the external jaws, and by this one we can find out the dimension of the any object. We can, if we want to find the diameter of any object, if we want to find the length of any object, then if we fix it, the object that we have to find out the diameter, radius or length, we have to fix it in between both the jaws, and we can easily find the radius or diameter or length of any object. Okay, that means this one is called the external jaw, outside jaw or external jaws. Okay, outside jaws or external jaws, and this one is called the inside jaws. Okay, inside jaws or internal jaws. Okay, that means two part already written. Third one, external jaws, J1 and J2. Fourth one, internal jaws, and that will be J3 and J4. Okay, by the use of the external jaws, we can find out, again I'm telling this thing, by the use of external jaws, we can find out the dimension, length, diameter or radius of any object. If any unknown object is given, and if we have to find out the length of that object or diameter of that object or radius of that object, then by keeping the given unknown object in between both the jaws, we can easily find the length, diameter, radius, or that thing we can find out. Okay, now last one, fourth part is internal jaws. Okay, internal jaws, by the use of internal jaws, we can find out the dimension of the hollow sphere. Okay, by, if we want to find the dimension of the hollow sphere, fix it there, just expand it outside. Okay, once it is going to touch it, you can find out easily the main scale reading and Vernier scale reading. Main scale reading and Vernier scale reading, I will explain it afterward, but right now try to understand what is the major part. Main scale or fixed scale, then Vernier scale, then third one is external jaws, J1, J2, internal jaws, J3, J4. Now the last part, fifth one, is tail. This one is tail. Okay, by the use of this, tail, just suppose this one is the Vernier calipers, just behind it one scale will be there. Okay, and once it is, by the use of this screw, or if once we are going to keep your thumb here, one also point will be here, thumb, and once we are going to slide it above the main scale, again listen, if once we will slide the Vernier scale above the main scale, then this tail will also, that will be attached just behind the main scale, it will also come out. Okay, that means if suppose once we are going to slide it above the main scale, okay, if we slide the Vernier calipers, Vernier scale, okay, if we slide the Vernier scale above the main scale, then this tail will also come out. And if once the tail will come out, then by the use of this tail, we can find out the depth or height of the liquid. That means if we want to find the depth of the liquid, or if we want to find up to what height, the liquid is filled in the glass, then by the use of this tell we can find out the depth, up to what height the liquid is filled. And how? Suppose this glass is given, okay, and if you are going to insert this tell here, okay, then by this position of the still, we can find out the reading of the Vernier caliper, the reading of the Vernier scale as well as the main scale reading we can find out. Okay, that means there are 5 major parts of the Vernier calipers. Okay, there are 5 major parts of the Vernier calipers: main scale or fixed scale. Okay, then Vernier scale or movable scale. Why it is known as movable scale? Because it can slide over the main scale. Okay, and by this scale we can find out the corrected length. If any error is there, then by the use of this Vernier scale we can find out the corrected length. Now the next one is external jaws. External jaws, it will be below it, both the jaws will be there. And also keep this thing in mind, here both the jaws is fixed one. That means J1 it will be fixed, J3 will be fixed, only this J4 and J2. Okay, again I'm telling this thing, J1 will be fixed, it it will not be movable. Okay, J3 will be also fixed on the main scale, only the J2 and J4 jaw will be movable one. Okay, J1 and J3 will be fixed one, while J2 and J4 will be movable one. Okay, this is the construction of the Vernier calipers. This is the construction of the Vernier calipers. Okay, now come to the next thing, that is the diagram. I am leaving it because maybe once we are going to explain the pitch or least count or rest of the explanation of these things, so it will be needed. So the diagram I am going to leave it. On the basis of the diagram I will explain the least count as well as the pitch, as well as the rest of the things I will explain on the basis of the diagram. So diagram I am leaving it, rest of the thing I will write it down. Now see the next one. Next one is uh, by what principle it will work. The principle of Vernier calipers. Principle of Vernier calipers. Okay, see, once we are going to join both the jaws in Vernier scale, there will be 10 division. Basically, for practical purpose or basically for the experiment purpose, once we are going to use the available Vernier calipers in the market, that will be each Vernier scale, it will having the 10 division. Okay, Vernier scale will having the 10 division. Okay, this Vernier scale will having the 10 division, and once we are going to join both the jaws, this both the jaws is going to join. So this 10 Vernier scale division, again I am telling this thing, in Vernier scale there will be 10 division. In Vernier scale there will be 10 division, and once we are going to join both these jaws J1 and J2, once we are going to join both the jaws, then in this case the 10 Vernier scale division is equal to 9 main scale division. Okay, 10 Vernier scale division, that means I am going to draw the diagram here. Suppose this one is the main scale. Here see the diagram. Suppose this one is the main scale, and here it's a Vernier scale. Okay, so here 0, this is the Vernier, and this one is the, here it's the main scale. Okay, and it's a Vernier scale. So this one I'm going to draw it here like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, here 0 and here till 10. That means, see from the diagram, 0 to here 10 division is given of Vernier scale. Okay, 10 Vernier scale division is equal to the 9 main scale division. Once if you want to check it, once you will see the apparatus, just join both the jaws, and if once you are going to join both the jaws, you will find 10 Vernier scale division, it will be equal to 9 main scale division. Okay, now so one Vernier scale division, VSD stands for Vernier scale division, and MSD stands for main scale division. Main scale division. So VSD Vernier scale division and MSD main scale division. Okay. Now one Vernier scale division is equal to 9 upon 10 MSD. Clear? 10 Vernier scale division is equal to 9 main scale division. Okay, then 1 Vernier scale division, it will be equal to 9 upon 10. So here what you will get, 0.9 MSD, 0.9 main scale division. Now already we are knowing in each centimeter there will be consist of 10 division. Okay, in each centimeter there will be consist of 10 division, and if there is 10 division, okay, if there is 10 division, then each division will consist of 1 millimeter. Okay, that means we can write 0.9 millimeter. That means 1 Vernier scale division is equal to 0.9 main scale division, or we can write 1 VSD is equal to 0.9 millimeter. Okay, that means if we want to find the difference between the 1 main scale division and 1 Vernier scale division, if we want to find the difference between the 1 main scale division and 1 Vernier scale division, so it will be equal to 1 millimeter minus 0.9 millimeter. So you can write 0.1 millimeter, or we can write 0.01 centimeter. That means according to the principle of Vernier calipers, if we want to find the corrected length of any object by the use of Vernier calipers, then we can find out the corrected length up to 0.1 millimeter or 0.01 centimeter. That means if we are going to use the Vernier calipers, then we can find out the corrected length up to 0.1 millimeter or 0.01 centimeter. Clear this one? Again, those who have not seen this one, just see it. If you want to find the difference between both one, or if we want to write the principle of Vernier calipers, by what principle it works, so once we will join both the jaw, we will find 10 Vernier scale division is equal to 9 main scale division. Okay, once we will join both the jaw, we will find 10 Vernier scale division is equal to 9 main scale division. Okay, now 1 Vernier scale division equals to how? What you will write? 9 upon 10 MSD, and since already I have explained, each unit or 1 centimeter, it will consist of 10 centimeter. So that means 1 MSD, 1 main scale division, it will be equal to 1 millimeter. So if you are going to write 0.9 MSD, so we can write 0.9 millimeter. Okay, so the difference between the, if we want to find, because already I have explained this, the once we are going to join both the jaw, then 10 Vernier scale division, 10 Vernier scale division is equal to the 9 main scale division. That means there will be some difference in between the Vernier scale, main scale division and Vernier scale division. So by this way we can find out the difference between the one main scale division and one Vernier scale division is equals to the 1 millimeter minus 0.9, or we can write 0.1 millimeter or 0.01 centimeter. That means by the use of the Vernier calipers we can find out the corrected length up to 0.01 centimeter or 0.1 millimeter. Okay, now till here I have explained the principle. Now the next topic is come to the calculation part, how we can find the pitch. Okay, how we can find the pitch. Before starting the pitch, first of all of you must be knowing about the how we can define the pitch. How we can define the pitch. If we want to define the pitch, okay, if we want to define the pitch, the smallest value of the length, the smallest value of the length which can be read directly from a main scale accurately. Okay, the smallest value of length means, suppose this one is the main scale. Okay, its smallest value, or suppose any length we are going to measure it. Okay, then how much accurately we can measure it by the use of main scale directly, not using the Vernier calipers. Okay, so the smallest value of length which can be read directly from a main scale accurately, not by using any other scale, by directly by using the main scale. The is, again I am telling this thing, try to just listen the definition. The smallest value of length which can be read directly from a main scale accurately. Okay, the smallest value of length which can be read directly, okay, from a main scale accurately is called what? Pitch. Okay, now the formula for pitch is pitch equals to 1 unit upon number of division, okay, pitch equal to 1 unit upon number of division in 1 unit. Okay, 1 unit. Now already I have explained, in 1 unit there will be 10 division. Okay, in 1 unit there will be 10 division. So 1 upon 10. So it will get 0.1 millimeter. Okay, 0.1 centimeter, not millimeter. Okay. So because 1 unit consists of 10 centimeter, 10 division. 1 centimeter consists of 10 division. So pitch equal to unit upon number of division in 1 unit. So pitch 1 unit 1 by number of division in 1 unit. Since already I have explained, in 1 unit in 1 centimeter of the main scale there will be 10 division. Okay, so 1 upon 10, that will be 0.1 centimeter. Okay, again I am going to just going to explain the definition. The smallest value of length which can be read directly from a main scale accurately is called pitch. Now, after pitch come to the least count. Least count, that means how much accurately we can measure it. So least count, just see it, the definition of least count. Okay, the measurement of the small length which can be taken by an instrument. Okay, the smallest length measured by an instrument accurately. Okay, again listen. The measurement of the smallest value which can be measured by an instrument accurately is called least count. Okay, one more definition of the least count, you can write it. The difference between the one main scale division to one Vernier scale division is called least count. This definition you can also write. The difference between the, because already I have explained in the principle of the Vernier calipers, once we are going to find the 10 Vernier scale division is equal to 9 main scale division. So the difference between the one main scale division and one Vernier scale division is equal to 0.1 millimeter. Okay, so here on that basis we can also define the least count. So least count is the difference between the one main scale division to one Vernier scale division. This thing also you can write it. The difference between the one main scale division to one Vernier scale division is called the least count. Now the formula for the least count equals to what you can write, pitch upon number of Vernier scale division. Okay, pitch upon number of Vernier scale division. So pitch already we have got 0.1 upon, okay, already we have got pitch 1 unit, 1 centimeter, 1 centimeter consists of 10 division. So 1 upon 10, what I have written, after dividing it, what will get? 0.1 centimeter. So least count equals to pitch upon number of Vernier scale division. Already I have explained from the diagram. Vernier scale division will consist of 10 division. So that means 0.1 upon 10. So what you can write? 0.01 centimeter. That means the least count of the Vernier calipers will be how much? 0.01 centimeter. Okay. Least count you have to find out, because until and unless the least count you are not going to find out accurate reading for the accurate measurement of the any length, any diameter, any radius. Okay, for the accurate measurement least count is compulsory to find out. Okay, one more thing, if once the number of division in the main scale or Vernier scale, it is going to change. The number of division in the Vernier scale division or main scale division, it is going to change. The rest of the things, that is pitch, will be also affected, least count will be also affected. Okay, once the number of division in the main scale or Vernier scale division, it is going to change, pitch will be also affected, as well as least count will be also affected. Okay, because already you have seen the formula, 1 unit upon number of division in main scale, here number of division in the Vernier scale. That means once the number of division in the main scale or Vernier scale, it is going to change. Then rest of the things will be also affected. Okay, so try to understand the concept. Once you are going to solve the numerical problem, especially the numerical problem, so keep this concept in your mind. If, because formula is pitch equal to unit upon 1 unit upon number of division in the main scale or number of division in 1 unit, and here the least count formula is least count equals to pitch upon number of Vernier scale division. Okay, so I am taking the example. Suppose generally we are getting 10 division in the Vernier scale. Generally we are getting 10 division in the Vernier scale. But suppose if in place of 10 division, if 20 division, or suppose the pitch amount is going to change. Okay, so here I am taking the example. Suppose here in place of 1 unit there are 20 division. So if in 1 unit there are 20 division, so see 1 upon 20, that will be 0.05 centimeter. See, you have seen this one. That means here the this thing has changed. This thing has changed, and if this will be changed, so this will be also. Okay, that means keep this concept in your mind. If once the number of division it is going to change, so the rest of the things will be also changed. That is, pitch will be changed as well as the least count will be also changed. Okay. Now come to the next one. Till here you have find the how we can find the what is the major part of the Vernier calipers. Okay, what is the functioning of the each and every part, as well as also you have find how we can find the pitch and least count of the given object of the given Vernier calipers. Now come to the next one, how we can take the zero error. Zero error. Zero error. Why it will be zero error? Because in the very beginning I have already explained that without any error you have to find out the diameter of the given object, length of the given object. So that means it will be error free. So maybe the Vernier calipers you have got, it can be also some error. Most probably in case of the Vernier calipers in screw gauge, you can get most of the time you can get the some error. Most of the time you will get the error in the screw gauge experiment. Okay, but once you are going to just take the Vernier calipers, so in Vernier calipers most probably it will be correct one. It will be no error, error free. But you must be knowing what is zero error. What is zero error? Zero error means, it is the diagram. So if already explained from the diagram, if suppose this one, the diagram I have taken, suppose already explained there are two jaws will be there. Here Vernier scale will be there. In Vernier scale there were 10 division. 5, 6, 7, 8, 9, 10. Here 0. Main scale 4, 5, 6, 7, 8, 9, 10. 1. Here also some division will be there. And 2. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Is it 2? Then here some more division. 5, 5, 1, 2, 3, 4, 5, 3, like that. That means this one is the construction of the, here also, 2 will be there. Okay, this one is the diagram. Now, this one is J1, J2. Leave it. Again, I'm not going to erase it. J1, J2, J3, J4, Vernier scale, and this one is the main scale, and this one is the tail. Okay. Now, see, once you are going to join both the jaws, okay, once you are going to join both the jaws, and if the zero of this very first division, this is very first division of very first division of Vernier, as well as Vernier scale, as well as the very first division of zero of the main scale. Okay, again listen, if the once we are going to join both the jaws, and if zero of the main scale as well as the very first division of Vernier scale, both are getting in the same line, like that. Here, point to point contact should be there. Okay, if the zero of the main scale, both are coincides to each other. Okay, that means no error is there. Okay. Got it? If once we are join both the jaws, and if zero of the Vernier is zero of the main scale and very first division of the Vernier scale, both are coinciding like that, exactly coinciding, that means no error is there. Okay, and if no zero error is there, but if suppose it is not coinciding, it is getting like that, it is getting like that, then that means there will be error. Okay, if both one zero of the main scale as well as very first division of Vernier scale, both are coinciding, then that means no zero error is there. But suppose if it is not coinciding like that, if it is coming here, then that means error is there. And there will be two types of error: positive zero error, and positive zero error and negative zero error. Okay, if the suppose this one is the main scale, okay, and if it is going this side, zero of the Vernier scale is going this side, right hand side, that means it will have the positive zero error. Again I am telling this thing, suppose this one is the main scale and here it's a zero of the main scale, and the Vernier first division here, this is the first division, 1 2 3 4 5 6 7 8 9 10, this is the Vernier scale. Okay, just see, it is going this side. Okay, it is going this side, that means if zero of the Vernier scale, it is going right hand side, zero of the main scale. Okay, again I am telling this thing, if zero of the, if the very first division of the Vernier is going right hand side of the zero of the main scale, so it will have the positive zero error. Okay, if, see, you can see zero of the main scale is here, and very first division of the Vernier, it is here. That means if zero of the if the very first division of the Vernier, it is going right hand side of the zero of the main scale, then it will have the positive zero error. Positive zero error. Okay, and its correction will be negative. Keep this thing in mind. If positive zero error, correction will be negative, and if negative zero error, correction will be positive. Reverse in nature. That means for the calculation point of view, we have to use the positive zero error, correction will be negative. Negative zero error, correction will be positive. Now see, and if in opposite manner, if it is going this side, if this one is shifting this side, it is coming this side. Suppose here I am going to give the example. Here 0 and here first division 1 2 3 4 5 6 7 8 9 10, like that. See, the zero of the very first division of the Vernier is shifted this side, left hand side. So if the very first division of the Vernier is shifting left hand side of the zero of the main scale, then it will have the which error? Negative zero error. Which error? Negative zero error, and its correction will be positive. Keep this thing in mind. If once the positive zero error, when the very first division of the Vernier scale is shifting right hand side zero of the main scale, then it will have the positive zero error. And if the very first division of the Vernier scale, it is shifting left hand side of the zero of the main scale, then it will have the which error? Negative zero error. Correction will be, in this case, it will be negative in positive zero error, and in this one, what is the formula that you have to use it? In this one, so correction what will be? Correction what you will write? Minus Vernier scale division coincides. Least count minus n into number of Vernier scale division coincides. Okay, n into n means least count. Least count multiplied by number of Vernier scale division that will be coinciding. N is the least count is the 0.01. Okay, and see, out of 10 division, again I am telling this thing, see, out of 10 division, which division is coinciding to the any division of the main scale. Again I am telling this thing, out of 10 division of the Vernier, you have to check which division is exactly coinciding to the any division of the main scale. That means here least count multiplied by number of Vernier scale division, that is going to coincide. So suppose seventh division it is going to coincide, so it will write 0.01 into 7, so it will get 0.07 centimeter. Okay, now here if we want to calculate the negative zero error, okay, if we want to calculate the negative zero error, so negative zero error equals to n minus number of Vernier scale division coincides multiplied by least count. How many division it is given? Suppose 10 division it is given. Okay, and number of division coinciding 7 division is, suppose here also here 6 division is coinciding. Okay, so 10 minus 6 into 0.01, that is 0.04 centimeter you will get. By this way you can calculate the positive zero error and negative zero error. Okay, by this way you can calculate the positive zero error and negative zero error. Now till here this is the compulsory part that you must be knowing. Now the next one, if you want to use it and if you want to use for finding the diameter of any object, then how we can find the diameter of the given object. Okay, till here I think everything is clear. Positive zero error clear, also negative zero error also clear. Only that thing I have to explain how we have to use it. Now come to the how we can use it. Suppose if we want to find the diameter or radius of any object. Okay, if we want to find the diameter or radius of any object, so first of all what the thing you have to do it, keep the given object here in between both. Okay, suppose you have to find out the radius or diameter of the any sphere. So if we want, keep the given sphere in between both the jaws. Okay, keep the given object in between both the jaws and properly attach it like that. Properly, it should be properly keep in between both the jaws tightly, and then here from this screw you can tight it. Okay, properly attach in between both the jaws, and from this screw, above the screw, you can tight it so that it should not be shift here and there. Okay, after taking this one, after putting the given, two things you have to find out. First one, MSR, main scale reading, and second thing you have to find out, VSR, Vernier scale reading. Vernier scale reading. Okay, for finding the MSR, what the thing you have to do it? If you want to find the main scale reading, if you want to find the main scale reading, then check the very first division. Check the very first division of Vernier on the main scale. Again, I am telling this thing, if you want to find the main scale reading, because two things you have to find out, main scale reading as well as the Vernier scale reading. Okay, so suppose the very first division of Vernier on the main scale, it is at, see, it is at exactly at 2. You can check it. You can properly check it. Just see it. Exactly, it is at 2. It is exactly at 2. Okay, so by this way you have to write the reading 2.0 centimeter. Okay, That means 2 point ms are reading 2.0 centimeter. And if suppose it is not exactly coinciding, it is coming in between 2 and 2.1. If suppose it is not exactly coinciding to 2, suppose it is coinciding in between 2.1 and 2, so write the previous one, 2 2 centimeter. Don't write 2.05. Sometimes the students are writing 2.05, it will be not correct, because already by the use of Vernier caliper, by the use of the Vernier scale, whatever the error will be there or whatever the correction will be there, it will be compensated. So don't take tension regarding this one. If you are going to write the if it is coming in between, so don't write 2.05 or 2.05 or 3.05 like that. Don't write it. If it is coming in between, write the previous reading. That means if it is coming in between 2 and 2.1, so write 2 centimeter. And now second thing, VSR. If you want to find the VSR, then check out of 10 division, then check out of 10 division which Vernier division is exactly coinciding to the any division of the main scale. If you want to find